G'day viewers of this Rodney the compressor. I'm going to call this thing Rodney. Knock knock knock. I've had it on a low setting and it seems to have worked. I gave this a good play around and whacked it and now it works. Look at that. Looks like a defrosted too. Fully frosted and defrosted coil. Nice. Nice and cool in there. Anyway, listen to that knock 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 knock. Got good heat rejection, I'll tell you that. R152A is good stuff. Why waste it blowing dust out of computers when they could use it to keep your beers cold? It's way better suited to keep your beers cold. Good stuff. I like that. This has a far better, more practical use than dusting out electronics. Keeping beers cold. Much more practical use for this stuff. Good old dye fluoro methane. It's actually pretty good value for money too, being cheaper than high fuel as I said before. I'm happy with that. I'm running it through some RCDs too for additional safety. It's something you should do anyway. But that's alright. Well, quite well. There's a hole in the bottom of the drains. Under that little tray, there's a drain hole. And the water runs down here, down those spouts. You can see it runs down here, down those channels. Into a drain underneath there. And it's supposed to be a tray that slides under there, which is missing. It wasn't there when I got the fridge. Not going to matter anyway because it just evaporates to the heat of the compressor, evaporates the water. It's not a shed. It's got nowhere ready to go, it'll just dry up anyway. But it looks like the defrost is working everything, which is good. The cycle the defrost is a reversing cycle valve. Basically, you reverse the cycle, dumps the hot gases from the condenser into the evaporator. And that defrosts. There's a sensing bulb. The other one you see too, there's one sensing bulb, which shows you that. When it feels it's warm enough, it knows the defrost's finished. And it clicks back on, shuts the reversing valve, and the compressor kicks on again. Reliable, and a bugger all to go wrong, an energy saving way to defrost your fridge. Versus nowadays, you have a circuit board which turns on a 200 watt heating element in your freezer compartment, which burns up your power bills. And there's more stuff to go on because heating elements are expensive, especially the glass. There's a glass type, which you can't get in certain model fridges anymore. It's just crazy. Plus, I need additional fusing protection so that they don't overheat and melt the plastic in the fridge and catch it on fire. Something like this, there's just nothing to go wrong. There was a time when fridges are the most reliable household appliance ever made. Now, not nowadays, now it's not. Absolutely rubbish nowadays. Anyway, my experiment was probably about, what, 200 grams. That's about what I put in there. I stabilised my can. I've written down the original weight when I first started. Put the tank down on a stable surface. Did some calculations, yeah. 200 grams of liquid I dumped in there was about right. So It's a bit much for a domestic fridge, but given the, as I said, given the size of the system and the compressor shell, the compressor itself is almost as big as this bloody tank. About as round as that, almost as hot as the size of this bloody tank. So, yeah, kind of makes sense. But she's got a full charge now. Works really well. Bloody good heat rejection. Anyway, budget refrigerant. Bloody works well and works wonders. Why waste the blow and dust out of stuff when it has a better practical use of keeping your beers cold? Anyway, that'll be enough for now. Thanks for watching.